Hi there, everyone. Let's get started with the external and basic heart features. Okay, so starting off here, we have the apex. So some of these are going to be really basic features, and the other ones are going to be a little bit more involved, but they are all really important to know still. So the apex, like I said, so that's going to be kind of the pointed end here of the heart, the apex. And it's interesting to note that a lot of people think of the heart as being positioned in the chest, kind of in this orientation. So, kind of like this is the superior portion and this is the inferior portion. But in reality, it's much more so that this apex is actually tilted out towards you, coming out at you in the screen. And then the base of the heart, which again is the area opposite of the apex, is kind of lying just like distant to you. So, it's almost like if the base of the heart were staying in the computer screen, but the apex is coming out at you. That's actually more of the appropriate orientation of the heart and the chest. So just something to keep in mind as we kind of go through this. So next we have the great vessels. So the great vessels are located at the base of the heart. And at the base of the heart, remember opposite of the apex, at the base of the heart, we have the aortic arch, the superior vena cava, and the pulmonary trunk. Okay, so now you might be kind of familiar with some of this, so I'll just do a brief little synopsis of each of these. The aortic arch, that's going to be taking, or the ascending aorta going out to the aortic arch, that's going to be taking oxygenated blood out to the body. It's going to be taking it everywhere. And then next, the superior vena cava, that's going to be receiving venous drainage from the superior portion of the body. And then the pulmonary trunk is actually going to be taking deoxygenated blood from the lungs to the pulmonary arteries, which are going to be going to the lungs to become oxygenated once again. Okay, so remember, the heart is really functioning as like almost two different sides of a machine. Okay, one side is going to be working to take the deoxygenated blood and send it to the lungs to then become oxygenated, rich or oxygen rich blood, coming back to the heart and being pumped out to the body, right? Because there's no sense in pumping around deoxygenated blood. So remember that right side of the heart is going to be all touching deoxygenated blood, and the left side of the heart is only touching oxygenated blood. And of course, this is if there are no pathologies present and everything is normal. And then finally here on this page, we have the inferior vena cava. So the inferior vena cava, just like remember we had the superior vena cava, the inferior vena cava is going to be coming up from more of the inferior portion of the body, so the name makes sense. And again, that's going to be draining the venous drainage from the inferior portion of the body. And we'll see, actually, there's a nice photo of it here. So we have the inferior vena cava, the superior vena cava that we just went over. This is a posterior view of the heart. So you can kind of see how those two are almost like coming in and dumping into the same place, okay? And that same place, in this case, is going to be the right atrium, okay? So we have, continuing on with our names here, our terms, we have the coronary sulcus. So the coronary sulcus is going to be this somewhat deep groove on the, or shallow depression on the posterior surface of the heart. And that's going to be separating the atria from the ventricles. So the ventricles are lying down here and the atria are lying up here on top. And then we have the coronary arteries, and the coronary arteries are essentially the first branch off of the aorta. And someone once told me that the coronary arteries are the first branch off of the aorta because the heart is greedy. The heart needs to feed itself first. So the heart makes sure that it gets its own oxygenated blood before anything else in the body. So remember that, the heart is greedy, so the first branches off of the aorta are the coronary arteries. And that's going to be, like I said, working to supply the heart. And remember, the heart actually is a huge drain on oxygen demand. The tissues are very sensitive to hypoxemic damage. So that's something that's very important, that these coronary arteries are patent and allowing blood to flow through them so then the heart can continue to contract. Next, we have the coronary sinus. And so that coronary sinus is going to be lying within that coronary sulcus. and it's actually going to be draining the deoxygenated blood from the heart. So it's going to be like the venous drainage for the heart. Okay, so all of that spent oxygenated blood, no more oxygen in it, it comes back up through the coronary sinus, and it's eventually going to drain into the right atrium again. Okay, and you'll see a lot of these diagrams repeated, but they actually are very helpful. All right, next we have the ligamentum arteriosum and the ductus arteriosus. So I gave these two their own slide and I put them together for a specific reason. So these two structures are actually somewhat like similar structures, except they change a little bit based on the life, the point in time of the life of the person. And so in this case, when an embryo is present, there's this communicating vessel here called the ductus arteriosus. So now when an embryo is in utero, it's actually advantageous to have flow, shunting between here. But then once you are born and your heart is functioning on its own, you are no longer relying on the maternal source for the oxygenated blood and pumping abilities, then this actually becomes just like a ligamentous structure. So you can actually have conditions called like a patent ductus arteriosus, where this stays open, and it can cause a lot of problems with the shunting of blood and inefficient flow of blood. So just remember that those two are similar, but again, different based on the life cycle or the point in time of the individual. Next, we have the interventricular sulcus. So remember, sulcus is just like a shallow groove or a shallow depression. So coming down here, we know that we have, again, one ventricle and another ventricle. So the interventricular sulcus is going to be running right between those two ventricles. And then within the interventricular sulcus, we have the left anterior descending artery. So a lot of people actually refer to it as like the LAD, just again, abbreviating LAD, LAD artery. But that's going to be lying right here, this red structure here. So the left anterior descending artery, because again, we're on the anterior surface of the heart. And that's, again, going to be separating the left and the right ventricles. So next we have the circumflex artery. So the circumflex artery is, or circumflex branch of the left coronary artery, is again just a branch coming off of the left coronary artery. You can see it kind of coming up here. And the left coronary artery is going to be bifurcating or separating into the LAD and then also into the circumflex branch right through there. Okay. And then the posterior interventricular artery. So I'm gonna, let's see, I'm gonna flip really quick to a posterior photo. Oh gosh, do I not have one? I know I do. Okay, so then the posterior interventricular sulcus is there, and again, the associated artery would be running right through there. Okay, sorry about that. Okay. And then we have some more general terms. I kind of saved these for the end because I think that most people are somewhat familiar with the heart. But again, we have the auricles. So auricle actually is kind of referring to like an ear-like appendage. So those are kind of just hanging out here associated with the atria. And again, the atria are going to be these larger than the auricle, but still smaller than the ventricle structures lying just up here on the superior, or if you will, deeper surface of the heart if you were looking at a person head on. And then again, the ventricles are going to be the larger structures, the larger chambers down here that are really going to be the main pumping force, and they have much thicker heart muscle of the wall. Okay, so again, just kind of going back to basics, the pericardium. So remember, the pericardium is a sac that's encasing the heart. The function of the pericardium is to allow the heart to beat forcefully and contract really hard without causing any friction to nearby structures or to the actual heart itself. So remember, there are like two layers to the pericardium. So there's the fibrous pericardium, And then there's the serous pericardium. So fibrous is on the outside, serous is on the inside. And then this little blue line here is, again, if this is just like a little snapshot through the wall here with the pericardium and the heart, the excuse me, the pericardial cavity. So that's where the pericardial fluid would lie. Next, just the heart wall layers. I'm sure you've gone over this in lecture, but just remember that the epicardium is going to be the superficial most layer of the heart wall, and it's very thin. Then you have the myocardium, which is going to be making up the bulk of the heart wall, and that's the actual contractile portion of the heart. So you have kind of like spiral fibers that are allowing for that almost like dish towel wringing motion of moving the blood and squeezing. And then finally, the endocardium, which is the internal most layer. So that's going to be, the endocardium is going to be the layer that is actually coming into contact with the blood that's traveling through the heart. All right, and then again, some more basic structures here. So we have the right AV valve. So AV is actually going to be referring to atrioventricular. And so again, that's just going to be looking at the right side of the heart. So remember, usually when we're looking at these photos, everything is flipped. So you'd be looking at it in a person right now. So this is the right side and this is the left side. So again, we have that right AV valve, so lying right there. It's also known as the tricuspid. So you'll hear these like common terms very often, I think. So just remember that the right AV valve is tricuspid. Next we have the left AV valve, and so the left AV valve is going to be lying right here on the left side. These are the ventricles that we're looking into right now, the little cutaway sections. So left AV valve, also known as the bicuspid or the mitral valve. And then finally, we have the pulmonary semilunar valve and the aortic semilunar valve. And so the semilunar valves are going to be connecting the ventricles to the great vessels. So the pulmonary semilunar valve is going to be going out to the pulmonary trunk, okay? And then the aortic semilunar valve is going to be going from the left ventricle up to the aorta. So again, those names kind of make sense with where they're going, to the pulmonary trunk or to the aorta, respectively. But again, all of these names are very important to know and to recognize when you're looking at the flow, that you can actually visualize all of these things and know all these structures that it's running through to get to a certain area. And then just remember too that the interventricular septum, that's going to be lying right between the ventricles, and that's going to be what's separating them. So interventricular septum right there. Okay. All right, and then a couple more terms to know is the chordae tendineae. So the chordae tendineae is actually going to be, it's kind of like, think of them as your heartstrings. So if someone says, oh my goodness, you're pulling on my heartstrings. So that's going to be actually pulling on these AV valves, okay? So these little stringy structures, artificial of course in this photo, but in real life they are, you know, these little cords that are running from these cusps, because there are cusps on each of the valves here. And they're actually running down to the papillary muscles, which is our next term. So the papillary muscle, if you can kind of see it here, it's like this rounded, almost like a nipple-like projection. So those papillary muscles are actually going to be functioning to pull down on those chordae tendineae, which are attached to the cusps, and then that will either act to open or close the valve based on the contraction here. And then trabeculae carne is just kind of like, it almost means like rough meat or like tortuous meat, stemming from Greek and Latin words. So your trabeculae carne is, they're actually going to be just lining the ventricles here. So again, you have your papillary muscle, and then kind of in just these other roughened areas, that would be the trabeculae carne. Okay, and then your pectinate muscles. So again, that's just going to be a lining that is going to be in the atria. And I have a nice chart here towards the end, just kind of going through where everything is, and it's kind of something similar to what you got in class, I believe. Oh, and then just a quick little trick when you're trying to remember everything with the heart as far as the flow and everything. So remember that all of your venous return is going to be coming in through the superior vena cava, the inferior vena cava, and that coronary sinus back there running on the posterior surface of the heart. Everything's going to be dumping into the right atria. From there, from the right atria or right auricle and right atria, then it's going to be going through the right AV valve into the right ventricle. So remember, all of this is starting on the right side, right? All of the venous return is coming to the right side. So just remember that you always try on a shirt before you buy it. So remember tricuspid for the AV valve here, tricuspid, and bicuspid on the left side here. Okay, just a little reminder of something to help you remember. All right, moving on, we have the fossa ovalis and the foramen ovale. So again, these are kind of like those structures that we saw earlier with the ligamentum arteriosum. So the fossa ovalis is again going to be like an embryonic structure. So it's actually going to be a hole that's communicating between the atria, that's allowing like free-flowing blood coming between the two areas here. And when you're an adult, that's not as advantageous. So it actually just seals up typically, like once you're born and once you start breathing. And if it doesn't, then again, you can have like a patent foramen ovale. So just remember, foramen ovale is what you should all have in your chest right now, just a shallow depression here in the right atria, and not a full-blown fossa or full-blown hole, letting the atria communicate. All right, and then the cresta terminalis, this is actually the right atria that's kind of flapped open here. The cresta terminalis is going to be this somewhat smooth band of tissue here that's running along the right atria. And again, just remember your positioning. The atria are actually posterior to the ventricles, not superior so much, as I feel like we all have been led to believe. And then this is just a reminder also, the atrioventricular or AV valves, they have cusps and they have chordae tendineae and they have papillary muscles. Because remember, when you have chordae tendineae, you need papillary muscles. And then when you look at the right AV valve, remember how it's called the tricuspid? That's because it has 3 cusps, okay? Very nice to remember. And the left AV valve, remember bicuspid, referring to the number 2, only has 2 cusps. Now we look at the semilunar valves. So remember, the semilunar valves are those valves that are going to be connecting or sandwiched in between the ventricle and then whatever highway they have to get out of the heart. So one of those great vessels. So with the semilunar valves, they operate purely based on pressure changes. So they have no chordae tendineae or no papillary muscle. They don't have either of those structures. So it's literally just the changing pressures that then causes it to either close or just be forced open. Oops. And both the aortic and pulmonary semilunar valves have 3 cusps. So they do have that in common. Just remember, no papillary muscle and no chordae tendineae. All right, and then finally, this is just this little chart that I took from Professor Craig's lecture. I do think it is helpful, just as far as seeing what structures are where. So you can refer back to what she has, or you can look at this one also. It's the same thing. But just remember, the musculi pectinatae is located in the auricles. And then you start to look at the atria, and the right atria also has the musculi pectinatae. It has the fossa ovalis, remember? And that's just that shallow depression that should be a remnant from embryonic life. And then also what's going to be dumping into the right atria? The superior vena cava, inferior vena cava, and coronary sinus. And for the left atria, things are a bit more simple. It just has a smooth wall. And then remember, those pulmonary veins are going to be dumping back into the heart. So the pulmonary veins are actually going to be bringing oxygenated blood. It was just oxygenated by the lungs, and it's going to be bringing it back into the heart to then get it into the peripheral circulation for the body. Okay, and then we have the right ventricle. Remember, the right ventricle is it would house the right AV valve, which is also known as the tricuspid valve, which of course has chordae tendineae and papillary muscles associated with it. Remember, it's lined by that trabeculae carneae, and it also houses the moderator band, which we'll talk more about, I believe, this week, with reference to the electrical system of the heart. Then we have the left ventricle, last but not least, and the left ventricle houses the bicuspid valve along with its chordae tendineae and papillary muscles, and it is lined by the trabeculae carneae once again. So that's all I have. I know it was a lot, it was a whirlwind, but I hope that you got something from this. Again, please, please, please contact me for my virtual office hours. I'd love to sit down and review any of the material with you guys, anything heart related, anything that you've learned in anatomy at all. That would be great. So just contact Professor Craig.